Good afternoon, distinguished guests, dignitaries, esteemed participants. I am Vikas Kumar. On the behalf of Ministry of Housing and Urban Affairs, I am privileged and honored to welcome you all to the 18th Urban Mobility Conference-cum-Exhibition 2025. The technical session is on electric vehicle technology, prospect, and challenges. And the session is being graciously chaired by and moderated by Mr. Sudesh Kumar, sir, an eminent electric engineer with over 50 years of experience, served in the Indian Railway for 37 years. Her vast experience in freight and passengers transport by rail and also cover urban transport domain. He is presently an advisor with GIZ who is collaborating with Ministry of Housing and Urban Affairs. To begin with the session, I am honored to request Sudesh sir to graciously guide the proceedings of the session. Over to you, sir.
Thank you. A very hearty welcome to all the people from the audience. I would like to take some time to introduce you to the panelists here. We are supposed to be having 5 stars, but I find one of us is probably on the way. But it's quite a good combination. I suppose Mr. Sanjay Chadha would be joining us very shortly. I had a word with him in the morning and he said he would turn up on time, but he was a little distant at that time from the place. Well, the panel comprises 5 stars, so I may say it's a very well spangled panel with an economist and a financial person from the KFW, Mrs. Veronica Pillards, a very widely experienced person from international affairs, and by personal interest, an enthusiast in non-motorized transport and sustainability. She is the head of the Asian wing for the development works. We have Mr. Sudhir Saxena. He has been an electrical engineer, then a master's, and he has been experienced with the power systems. He has worked with the telecom ministry, with the alternative fuels, and also in various innovative measures. And he'll be taking you through to the introduction of hydrogen trains, which incidentally are electrically driven. We have with us a vehicle designer, come implementer, come tester, and a person who has been involved in training of more than 40,000 people in managing electric fleets. A very, very wide experience in the terms of the types of vehicles and the types of equipment which go into it, and in making standards so that the equipments are interchangeable. Mr. Prashant Kumar Palani. We have Mr. Praveen Yadav. I would say that he's an avid golfer, and that is what he is good at. He's also good at pursuing his passion, which is electrification of the India's highways, and he is so committed to ensuring that charging does not come in the way of the rapid pace at which electrification is to take place in the mobility sector. He also is the director of Electrify, a very large charging enterprise in Gurugram and also in several other cities. And he has been contributing to the standardization in this charging business. Mr. Sanjay Chadha, I presume he will join, but I will make a mention that he's a mechanical engineer and a master's, and he has been working with the different ministries. And also, he is a person with a very, very versatile policy maker. Well, with that background of this panel, I'm sure it will be a rich exchange of ideas. But before I begin, I may like to give a brief background as to why we are meeting here. I think I'll take about 5 minutes time more. If you look at it, the electricity as a means of mobility came to this country somewhere in, really it took off in 1925 when electrification took place in Mumbai. The trams came a little earlier, and unfortunately, or the way we developed in this country, trams were pulled out from Delhi, from Chennai, and even from Mumbai. Some of the trams are still running in Kolkata. So in 1895 was the first electric tram in Chennai. In 1925 came Mumbai. The bus came in 1928 as a transport in Mumbai with the best company coming up. With that humble beginning, by now, if you look at it, the electric vehicles, we are very, very small in number as far as the transport is concerned on the cities. We have got about 45 crores vehicles on Indian roads. Maybe around 38 crores will be two-wheeler segment, 6.5 crores or so is in four-wheeler segment, and we have 20 lakh buses in India. But in the cities, if you look at the urban transport, the number of buses might be less than 50,000. And if you look at the pace of electrification, despite all the FAME 1 and FAME 2, the uptake has been very small, less than 1%, except for the two-wheeler segment, where today we may be having about 14.5 lakhs of two-wheelers, about 28 or 29,000 four-wheelers, and just about 5,000 electric buses. So I think we'll be taking views of the people as to what type of policies or what type of issues are involved, and how do we encourage and what changes should come about to increase the pace of electrification. Why should we have electric vehicles in urban areas? We need not discuss that part. We are all aware of the need for it, basically to clean up the air. And 60% of the vehicles will still be four-wheelers. By the end of this, by 2047 or so, we may be having something like 60 or 65 crore vehicles in India, of which we should have around 50 crores of two-wheelers, maybe around 8 to 10 crores of four-wheelers, and about 30 lakh buses. But in the urban areas, the population will be predominantly in four-wheelers and two-wheelers. The buses must be scaled up. So, with all that background as to why the electric uptake is slow, I thought I will begin with the charging part of it, because that is the biggest concern. The other concern being the range of the vehicles, and the last part is about their electric vehicles' susceptibility to the extremes of climate. We are aware that extreme climate events like floods or something, they take place. There are risks of fires, and then there is a concern every time and nagging that where do I charge my vehicle? So I think with that brief background, may I request Mr. Yadav, who himself has been a very, very avid enthusiast and a pioneer in setting up large charging systems, as to share his views as to what has prompted him to take this up at this scale, and what more needs to be done so that people are encouraged to buy and invest in the electric vehicles. Mr. Yadav, please.
It's a pleasure to be sitting beside everybody. Hope this mic is working. It's a pleasure to be sitting beside all the policymakers and experienced personnels in this industry. But yeah, the biggest challenges that we face in deploying the charging stations and in advancing the charging equipments and the policies which have come up from the government and implementing them on the ground basis is like, India is a very diverse country. And if we say we have to deploy a charger in the western region, Then there will be some demographic challenges in the southern region, like it's a coastal area, so the humidity is very high. So we have to deploy the charging station with those specific materials that won't decay during, won't decay due to the humidity there and the, demographic challenges there. So recently, specifying this, so we were deploying chargers in the northern region and the southern region as well of the country. And the challenges which we faced, that the equipment which we using in the northern region were decaying very faster due to the humidity. So we came up with the idea, why not change the materials so that the deployment is faster. So from the normal, iron, so we were considering the cost of the stainless steel in the southern regions and so on. But the challenges which we faced earlier was the connector types. So there were, initially when EVs came in India, there were 5 connector types. Now they have been reduced to 2, which is being universally used, and which is done by the government and deploying the policies that the CCS connector type should be universal, and that will be used in the future vehicles of the country. So that's one of the things that government is doing very well. And the recent FAME 3 policy, which emphasized on converting the buses, the public transport, into the electric vehicles. So currently in India, what we have seen as a consumer behavior, that people are reluctant to change and reluctant to shift to newer technologies until they have seen or they have seen the government implementing them or making them useful on the roads. Like as seen, in the initial phases, the government vehicles were converted to EVs, the ministerial vehicles, after which the transition happened, and the public, the users, started to believe that the EVs can be successful in India. The range anxiety was there, the newer technologies, so that the battery technologies were also older, and they have seen significant change in the past decade or so. But yeah, there's a lot to be done in the industry, but some challenges are being faced, and we are concerning ahead with the government and totally taking the views of the government and the consumer, that what all challenges they are facing and how we can assess them and put forward how we can solve those challenges in the future.
Thank you, Mr. Yadav. May I ask you to kindly clarify a bit from your side the number of charging stations available along the highways or in the cities? What would be the expected command area, and do you think that the provision today at different places, is it sufficient to excite the people from being confident about owning an electric vehicle? Should they increase, or you feel that would be bad for business?
Currently, in the initial stages, the vehicles that were launched were having a range of 150 kilometers, 200, 250. But currently, the range of the vehicles have been increased to 500, 600, 700. So, and even the highways, the good food chains on the highways are installing chargers on their food restaurants and hotels. So I think so that India is moving forward, but it will take a little time, as major of the highways are being covered, and the new policies are also stating that a charger should be at every 25 kilometers of the highway, and a bigger station for charging infrastructure should be at every 50 kilometers of the highway. So it is being resolved, but it will take some time, because grid availability is also a concern in some regions. The power is not sufficient to install bigger stations that will facilitate even buses and trucks in the future. So that is also another challenge on the highways that we are facing. But it will be resolved after some time. It will take some time to getting resolved, but yeah, it will happen.
Thank you. Mr. Prashant, I would like to, I believe you have a presentation. So if it is loaded, can we take Mr. Prashant's views? I may set the house rules, I should have did it earlier. we would expect the panelists to kindly take about 10 minutes in the first round, and that would leave another 5 minutes in the second round of questions which may arise. So, Mr. Palani, if you can take on the stage, please.
Sure. When I can even present without the presentation, so I feel better to stand and speak. Yeah. Good afternoon, everyone. So there is less energy I'm seeing. So good afternoon, everyone. So I am Prashant Kumar Palani. I am the Chief Technical Consultant for Haryana Mobility Solutions. We are basically a firm supporting investment agencies working in the electric bus and electric vehicle technology side. So the idea of this small session, I've been given 10 minutes of timeline. So before to start the session, I want to understand how many of you have driven electric vehicles and how many of you have experienced electric vehicles? Can you just raise your hands? Just to get some market trend data. Okay, got it. So I hope the people who have not yet experienced the electric vehicles should definitely give a try. And I believe I assure you that you will love them, definitely, right? So as part of a firm and the projects that we have handled, I have been closely working with almost all the different types of electric vehicles, starting from 48-volt electric scooter and up to 800-volt electric buses and even some construction equipment vehicles from firms like JCB and all. So we can very clearly see electrification is not just happening in the 2- and 3-wheeler segment, but also on the passenger vehicle segment, also on the bus technology. Especially, I see a very huge support, a huge push coming from the central government and also the state governments, which is very clearly visible in the FAME schemes and even the latest PM e-drive scheme, which has been released by the government. So definitely, yes, there are a huge change happening in the technology perspective. If you look at, I don't know whether the presentation was loaded, but if you look at a typical electric vehicle today, from a technology perspective, they are completely different from a IC engine vehicle. Even if you compare with a diesel and CNG, right? So especially if you look at, let me take the battery technology perspective. So the battery technology is no more the old battery technology that we have seen last 5 years back, right? There's a tremendous technology change. Today, we are seeing battery technologies for buses, the segments of buses, which can assure a 15-year of operation guarantee for the vehicle. And they can even ensure the buses can be operated to 1.2 million to 1.5 million kilometers, right? Can be assured for operation. So that's the kind of a durability, the longevity that the battery technologies which are currently offering, and there are few market players, global players like CATL. You must be knowing the Chinese market players like CATL and CALB, and there are few Japanese players. So mostly the battery technologies are currently held by these Chinese and the Japanese market players. But definitely from a electric bus perspective, they are definitely doing a tremendous work. And one more thing that is also changing is the energy density. Today the battery technology, if you imagine that earlier a battery which was offering 300 kilometer range, imagine the same size battery today can deliver up to 500 kilometer range. Because the energy density is very quickly changing, and we are advancing close to 200 to 300 watt-hour per kilogram of energy density, which is again making this technology very favorable for the operators from electric bus. So both the intercity and intracity applications I'm talking about, right? And of course, this trend is affecting even in the other markets also, not only electric buses, even in the 2- and 3-wheeler segment, especially the 3-wheeler segment. Have you seen the 3-wheeler segment, the trend which is happening? Currently, 35% of the market share in India's three-wheeler market, both the passenger cargo, both the markets are shifting towards electric, right? So, and very clearly it's visible that the operators who are dealing with three-wheelers, both the passenger and cargo segment, are really getting benefited from the electric vehicle, and that's the reason this 35% market share. I'm not including the e-rickshaws. If I include the e-rickshaws, it is going to be close to 57% market share, which is electric vehicle today. But I am looking at only from the L5 segment, which is basically the key segment which we have to look into, right? Throughout the country, if you look at down south, if you come to states like Kerala, Tamil Nadu, we don't see e-rickshaws, right? So it's majority the L5 segment vehicles. So considering the L5 segment, which is across all the states in India, we can very clearly see more than 35% market share already in India, and that is clearly because of the consumption. And if you look at the energy consumption perspective, electric vehicles are definitely doing magic. When during my technical due diligences, I was reviewing the energy consumption data for many of the electric bus operators in India, and I could see a typical energy consumption ranging from 0.8 watt-hour per kilometer means to 1.1 kilowatt-hour per kilometer. So it's again, the energy consumption is nearly 70 to 80% less compared to a diesel or even a CNG vehicle. So this is again making electric vehicle a very cost efficient and from a total cost of ownership perspective as well. So with all these things, yes, which is making this positive, but at the same time, what again I'm seeing is there are some challenges on ground level. There are some challenges which the government has to accept. I am seeing that there are some challenges like the depot allocations. You know, the electric bus depots are not allocated on time by the authorities to the electric bus operators. And you know very well, for the investment firms, it is very difficult. Even a 1 day or a 1 month, 1 week delay in the start of operation of the buses, it's going to end up in huge losses for the operators and even for the authorities. So it's very important that the clauses in our concession agreements have to be ensure that the timely operation, timely deployment, and timely allocation of land is provided for the electric buses and the operators, so that if the operations start on time and we can ensure that the real potential is taken out of it. And second, very important gap which I am seeing in the industry, a huge dependency on China. Whether we agree or not, when I go and open an electric bus and its component, almost 90+% of the component is directly linked to our neighboring country, China. And if we look at electric buses, particularly where I am having more connection with, if we look at electric buses as a long term, which should benefit, if we look at it is benefiting our long term future, I think our Indian OEMs should be specifically supported by our funding agencies in India, and the government agencies in India should provide financial support to the Indian OEMs in order to develop indigenous technology. Otherwise, we will definitely get into a huge technology risk in the upcoming years, because all the key components like traction motor, traction battery pack, vehicle control unit, battery management system, in all these components today, all our Indian OEMs are directly dependent on the Chinese firms. And very challenging and very alarming point is there are no proper long-term supply agreements between the OEMs and the component suppliers in China. And what is going to happen if in future, if such companies do not offer them, or if they stop supplying these components, what will be you imagine the condition of the market, right? So we are offering a 10-year, 12-year guarantee in our agreement, and we should ensure that the OEMs are having indigenous technology which should be implementable in India. And again, that needs some kind of a support from the government, and I urge government should provide financial support and the funding agencies should also take care of some of the support for the OEMs so that they can work on developing indigenous technology rather than directly getting components imported and doing it. Already some of these clauses are all covered in the latest PM e-drive scheme. Already I am seeing many OEMs have started assembling the complete motor inside their manufacturing facility. They are assembling the complete battery pack inside India, inside their manufacturing facility. But still, the child parts are still coming from China. So, so definitely a push is required in this to more indigenization. So that's what I was just talking about. So these are the key areas I think push is required. One is the battery technology. We have to focus on more indigenous battery technology. And second thing is from the traction motor, the focus should be on the non-rare earth material based motor technology development. And from a power electronics perspective, our OEMs should push more, go towards 1200 volt silicon carbide and gallium nitride technologies, which are highly efficient, high power density technologies. And again, charging side, we are already we have started seeing megawatt charging technology. And I believe this megawatt charging technology is going to be a game changer in the coming years, which is going to increase the wide implementation of electric buses and trucks, even for long distance travel. And finally, AI. People are talking about job losses going to be there in AI, but I'm going to only tell about AI's role in real-time data analysis. So let us use, our OEMs should use AI as a tool to analyze the real-time data coming from the electric vehicles. What is the efficiency drop happening in the winter, happening in the summer, happening in the different cycle of operation, and we have to plan the duty cycle in our design. So AI should be used as a tool to improve the energy efficiency and the operation of the electric vehicles in the market. So with this, I just thank the panel members for giving me this opportunity. And on the next round, I will be try to answer your questions if there is anything. Yeah, thank you very much.
Thank you. Mr. Sanjay Chadha, I believe you have joined us. Kindly come over. So, I would leave a question for you to answer later, Mr. Palani.
Yes.
One is that you mentioned about the battery sizes. The total cost of operation for ownership for the buses, it varies between some 59 or 60 rupees per kilometer for a diesel. And for electrics, the total cost of operation is coming to around, say, between 45 to 48, but depending upon the capacity of the batteries. And this data is available with batteries on the buses which are around 400 to 450 kilowatt hours. But the urban buses are adopting 200, 250 kilowatt hours. So kindly, when you come to your second round, you could let us know that you have been dealing with standardization as to whether we should really be standardizing the batteries for buses and for other vehicles, so that when the time comes for their second use, post their economic life, they don't become a burden for the environment and they can be used. But if we have got batteries of different standards, different capacities and different voltages, it would be a problem. And the second is a issue which I'll be addressing it to Mr. Sanjay Chadha and to you both. That would come with how do we encourage the OEMs to really take back the batteries and do something about it? Because today we may be adding about a gigawatt hours of batteries in the electric vehicles per year. But by the time we come to 2050, we would be almost 25, 30 times more. And after 10 years or 15 years, when these batteries start getting released, they would be becoming a threat for the environment unless reclamation facilities are provided or built up or some alternative use is found. So I would request you to kindly mull over it in the second round. Mr. Sanjay Chadha, you have come in time. Thank you. I have, with your permission, I have already introduced you earlier. So I will not repeat that. But he has been very, very versatile in the policy making body. So I will request you to kindly, you have a very small presentation. Do share that. Take about 8 to 10 minutes of time. Then maybe I'll be able to have, other than this one question, 2 or 3 more for you. Please.
Thank you very much, sir. It's a privilege to be here with 2 former railway colleagues, Sudhir and Mr. Sudesh Kumar. I transitioned from the government to work for Uber for the last 3 years. I had their public policy. So I would put the perspective of the ride-hailing industry in adoption of EVs. I have a small presentation. I request that to be loaded. And why I speak of the importance of ride-hailing is that, as you would know, a private vehicle, as per CSC, remains parked for almost 95% of its life. It moves only 5%. A commercial vehicle, on the other hand, moves around 20 times more than a private vehicle. So it's imperative that if you're looking at the environment, the thrust has to be to electrify the commercial vehicles, because that will give us more benefit in terms of emission reductions. Thank you. So should I stand or sit? Okay. Okay. Okay, this is a shot which explains why the time to act is now. We have the dubious distinction of living in the most polluted city in the world. We know that Beijing has been there, other cities have been there, but today we hold this dubious distinction. And NCR, amongst the top 10 most polluted cities, it said that 7 are in India. Not a very proud statistics, but it's a matter of fact, and it steps up the urgency to adopt EVs. Why EVs? Because it's a net zero tailpipe emission. So there should not be any doubt or hesitation that why we need to adopt EVs. We know that the toxic air is cutting lives short. It's crippling public health. Every year, the GRAP 1, GRAP 2, GRAP 3, GRAP 4, the CAQM struggles with it. And vehicular pollution is one of the biggest. The ecological clock is ticking for us, and the time to act is now. Let's look at what's happening globally. Globally, they are not choking to death, but the rate of adoption of EVs is much faster. I'll talk about some of the companies. Uber is committed to ensuring 100% of its rides on electric in US, Canada, and Europe. Why not in other parts? We'll come to that. Similarly, Lyft, another big competitor, has set a benchmark to operate a fully electric fleet by 2030. Bolt, which is a European ride-hailing giant, has committed that by the end of this year, it should have half of its rides on electric vehicles by 25. Didi, which is the biggest ride-hailing player in China, in 2022 had aimed to have 1 million vehicles, EVs. And China, incidentally, is doing the best in EV adoption. They claim that in Shanghai, 25% of the vehicles today are EVs. So this is where the global orientation is happening. Of course, in the last 8 months, there have been some policy differences which have erupted in the US, triggering a debate whether, is it going to be a faster transition or will fossil fuels stay longer? But nevertheless, Europe is very clear, the rest of the world is very clear that the transition to EV has to happen. Let's see what are the challenges in scaling up an EV for us. Of course, the upfront cost is much higher. The more important part is the resale market is indeterminate. So when we talk to our DCO, which is the driver cum owner, that why don't you buy an EV and give up your fuel vehicle, he goes to the bank. And the bank to whom he hypothecates the asset is not willing to take the risk on an EV like has a greater clarity on an IC vehicle where he knows that there is a resale value. So EVs have still to come up and reach a point where the banks can take that risk of funding EVs at lower cost. This drives up the interest rate from the drivers. Also, an individual driver has low credit worthiness as opposed to a bigger company. So all the EVs which were adopted in India came under what is called the fleet model partnership. You've heard of Blue Smart, you've heard of Evera. So if a company buys EV, it's able to get better rates. And financing rates are extremely important in the ride-hailing industry. There are infrastructure gaps, which we know we have to, because if we don't have enough charging infrastructure, there is going to be a real problem of commercial adoption of EVs. Linked to this is the range anxiety. I have experienced this myself in a Blue Smart ride where the driver told me, please switch off the AC because I don't know after dropping you off whether I'll reach the nearest charging points. There is also the problem of having better battery technology which can give us longer range. A typical taxi in Delhi NCR runs over 350 kilometers a day. So it should ideally not require a charging for that duration. And we hope that the PLI scheme that the government has taken out in ACC will really boost this battery technology and bring it in. Of course, there's government support, fiscal incentives, tax breaks, which play a greater role. I just thought I'll talk about a case. Blue Smart was one of the very successful EV models. It had a very high rate of consumer satisfaction. Despite high efficiency cost and limited ecosystem support, it led to a decline. There were other factors too, I'll admit, which played out, but it needed support. It needed support and it was a pioneer of sorts. Now, how do we drive sustainable mobility? How do we adopt willingness in electric ride hailing? Despite multiple new entrants, when Blue Smart and Uber Green were launched, there were just two models of Tatas, the Tigor and the EcoSmart. Today, there are plenty more models which are coming up. Yet, EV adoption remains slow. What is the reason that the targets which are set out for ride-hailing players to transition have never been met? There are financing and leasing barriers. There are slow charging turnaround. There is a low resale value and residual risk. And there are fragmented regulatory incentives. The NCR has 3 states which have their own EV regulations and their own EV mandates, instead of the NCR, Delhi, Gurugram, and Noida being integrated as one unit. Because the vehicle registered in Delhi has to now mandatorily be an EV, but not necessarily so in Gurugram or in Noida. So these are regulatory gaps which need to be addressed. Of course, as a company, we want more carrot and less of stick. I'm not saying that enforcement should not be there, but inducements can help more. We have lots of policies to lower the capex, the capital expenditure, through FAME 1, FAME 2, subsidies coming in. But is this enough? Do we have any policy to reduce operating expenditure? One of the simplest things we have suggested to the government is that if you do away with the toll that a commercial vehicle has to pay between Noida and Delhi or Delhi and Gurugram, it's 100, 120 rupees. If you just do away with it in every trip, most of the ride-hailing industries will see it as a very viable option and go to EVs. But we don't do that. The EV, commercial EV today pays the same toll which a fossil fuel commercial EV pays. This does not impact private vehicles because private vehicles don't pay tolls anyway, but it can reduce hugely the operating expenditure for commercial EVs. This is something that we've been talking about. We have dashboards, but Delhi government is working on a real-time verifiable dashboard. We hope this comes up someday because this would be really good in monitoring how the system works. So I've already spoken about OPEX, waive interstate tolls, strengthen battery swapping. This is more for two-wheelers because it's working well there. Enable innovative financing and leasing models, create PPP for infrastructure development, and harmonize state and central EV policies. We went to Telangana, which had a wonderful EV policy, except that the rates of electricity determined by the Electricity Commission was commercial rates, and Delhi has domestic rates. Now there's a big gap between domestic and commercial rates. So you are telling the state government that you should intervene and make sure that the cheapest electricity is available for EV charging. That is one thing which is very essential, and domestic rates are today the cheapest. In conclusion, I'll just say that NCR cannot afford a delay. pollution is not a static, it's a survival threat here. My children breathe poisonous air every day, and many of people, the people who relocate from NCR into the very congested Bangalore, do so for health reasons, do so for the air quality. And we need a collaborative push. We need combining incentives, infrastructure, and innovation, and make electric mobility the new normal. Thank you.
Thank you, Mr. Chadha. Before I'll come to the second round for you later, but you would be having a fairer idea about how the insurance companies treat the batteries for electric vehicles. In fact, if you read the fine print on the insurance policies for electric vehicles, the batteries practically are not insured. And that drives the customer away, because a battery is half the cost of the electric vehicle. And every time a person thinks that if something goes wrong, I only get whatever damages to the vehicles is there, but the battery is my responsibility. So this is something, what type of intervention by way of policy can be done for the insurance companies to encourage them. And second part is what to do about the batteries. How do we ensure the OEMs that we have asked you to take the batteries back at the end of their life? What do you do with it? I'll come to you later. Before we come to the hydrogen part, I will request Mrs. Veronica Pilars to kindly share her experience that we in India are a little lagging behind, at least time-wise. Maybe that our scales are different. But what has been the European and other countries' experience, that they have been able to scale up the EV adoption at a much faster pace, while we are still struggling at 1%, while the targets are 30% of replacements. There's a big gap to be covered. So how does the people with experience from Europe look at it and suggest?
Thank you. I'm well equipped now. Thank you, Mr. Kumar, for the kind introduction and also for asking this question. I think this is actually some perspective I can provide to this esteemed round of speakers. The perspective of the European experience and also the perspective of a financier that is strongly committed to sustainable mobility. So as a representative of KfW, a German state-owned development bank that is promoting sustainable mobility in India and worldwide, we are very often faced with exactly the same questions that you asked here. But before I come to this, I would like to give you the background of a European city and the European ecosystem that we have on the example of Frankfurt, where we are based at. And it's actually the 5th German city by size, with 7 lakh population. I understand by Indian standards it is considered rather a second-tier city. And we've heard a lot of the challenges of second-tier cities in India yesterday, so I think this might give you an outlook of what the ecosystem might look like with a good integration of different modes. So you mentioned this earlier. In India, you have had those modes also available. You removed them. In Frankfurt, we have 9 lines of light rail in the city. Then we have 10 lines of trams. We have 9 suburban lines, and this is for the 7 lakh population and the metropolitan region. So, and this is all already electric mobility. So it's been around a while, and it's serving well. In addition, we have multiple lines of buses, around 2,000 buses running the city, and those are slowly being electrified. So in Frankfurt, we have around 5% of electric buses running right now, and most of them are battery electric vehicles, and some 10 are running on fuel cells. So this gives you the impression this has been happening for years. So actually, I think and this is a good example of a middle-sized or bigger-sized German city. It's happening all over Germany and similarly in Europe. Actually, the operators in the European cities are facing very much the same challenges. Battery electric vehicles or fuel cells, it seems to be new. There are uncertainties in the operation, in the implementation, in the whole ecosystem, because it's not only the electric vehicle you're acquiring for the operations, it's a whole ecosystem coming with it that is different from the diesel buses. You have to adapt your depots, you have to have the management system, you have to implement all this digital ecosystem to monitor the batteries, to manage the batteries, to have predictive maintenance coming with it. And even to the European operators, it's something new. So not unlike in India, the take-up has been slow, and it is also heavily depending on subsidies. So we have had several programs from the German state and also from the EU. That's the carrot you have been talking about, but also we have to admit the stick is quite prominent in Germany and in Europe, because European Union demands 100% of bus fleet electrification in the coming 10-15 years. So there is an urgency to electrify the fleets. And what has happened in Germany is that every city is doing it on their own. So it's a trial tender for 10 buses here and 20 buses there, and we end up with the situation that years after introduction of the technology, actually there's maybe some 5% running on electrically. And here I have to admit, actually it's not India lagging behind, but Europe, and we have to learn a lot from India. What we see here is that due to the schemes like the PM e-bus saver scheme of MOHUA, India is introducing large-scale tenders and the large-scale implementation of electric vehicles, which helps a lot in our view, so that you avoid actually the mistakes we have made in the past, that every city has their own design and their own requirements and their own their own vehicle type demanding from the manufacturers. It is essential that you reach a certain degree of standardization in this case. And I think we're going to speak about standardization a bit more also, but this is already a first step, that if you have this large-scale tenders, you achieve already a certain degree of standardization in your vehicles. The other question, of course, as you rightly mentioned, the batteries. Also, the German operators are facing range anxiety and the same questions. What are we going to do with the batteries once they are not fit enough to be operated on the bus? How much is recycling going to cost us? All those questions, of course, are just as valid in Germany as they are in India. So here, interestingly enough, the so far operations show that actually the battery reliability is better than it was thought of. The studies of the ongoing operations show that the battery electric vehicles, at least, I'm not sure about the fuel cells, but battery, are already at a level of reliability that matches the diesel buses. So that's already a good news from Europe. In our case, it doesn't matter that much anymore. And then, of course, what happens if the battery does not provide the capacity anymore? It's an important question, and interestingly, once it is not fit enough to meet the high standards or high requirements of this heavy-duty operations in a bus, a battery is still at 70 to 80% of its capacity. So in Germany, there is a big segment coming up now for the second life use of vehicle batteries, which is being tried by the operators. For example, in Hamburg or in Hanover, that's another major city in Germany, the operator is running trials to have those vehicle batteries installed at the depots themselves for energy storage, and they are also used to shave the peak demands in the general grid. So if you imagine the scale up of electrification coming up in the next years and the amount of batteries that is going to start their second life, this may become a real really essential component also of grid stabilization and peak shaving just in the general grid, or what is being tried now, backups for neighborhood grids, for example. So there is a good use for those batteries. And again, to promote this, we will face the question of standardization. And third point on the batteries, the end of life, once they are really not fit for any use anymore. In Germany, we have a very precise and very strict regulation on this. So I think if it's not the case in India so far, this is, well, the stick that has to be in place. The manufacturers are required to take back their batteries. So this is by law. And the European Union also has issued some directives that request with an increasing percentage over the years to have recycling rates of the valuable materials and rare earths that are built in the batteries to be regained from those packs, starting from 50% going up to 90% in the following years. So actually there is a legislation in place that sets the framework, and it turns out there is a business case for this. So we were discussing how expensive is it going to be? That's a big headache also for the manufacturers. So it turns out with the price of the batteries going up due to the increase of the raw materials for them and also the higher demand globally, there is a good business case for recycling. And Germany is trying to position itself also as a manufacturer of batteries to reduce dependencies from imports. And recycling also helps reduce those dependencies because you can just reuse the materials to create new battery packs. And for example, there is BASF, a big German chemical corporation that is launching now a recycling branch of, just within its existent operations. And there are new startups, new commerces coming up, building their business model exactly on this. So actually, maybe that's the good news. Recycling may not be that big of a problem as it appears to be right now when you're at the beginning of the implementation of electric vehicles. Maybe just one last word. As a financier, I just wanted to stress, so if we're talking about the interoperability of the systems, the big scale up of electric vehicles. Even the second life, the use of batteries in electric utilities. The key to this is standardization. For us, it's very important that if we have a project suggestion to be funded, that we see that the relevant standards, be it ISO quality standards or environmental social governance safeguards, that they are followed. So this gives us already an assessment of the risks that are associated with the project and make them, this makes it financeable for us. So I think I'll stop here and just with my final message to encourage India on the path that you have already entered and drive deeper into also into the standardization of all those of the ecosystem that comes with electric vehicles. Thank you.
Thank you, Veronica. I think the key is standardization, and that is something which she did mention, that every city has got its own specifications and standards for the bus, for the battery, and until and unless we fall in line that there is a standard, and that helps in scaling up, it helps the industry, it helps everybody. I would like to invite Mr. Sudhir Saxena to share a different perspective from the climate point of view, because ultimately it is the object is to clean up the air, to clean up the cities and what we breathe. And he has been a very ardent enthusiast in pushing the hydrogen-operated trains in India. It's a reality now, almost. I would like him to also share his view that why not have hydrogen bus? Over to you.
Yeah, good afternoon, everyone. Thank you very much, sir, and for giving the opportunity for making a presentation, and particularly on the hydrogen train, which definitely is one of the upcoming kind of a technology, and we need to go probably with the hydrogen also. And the EV basically term only comes basically with the battery-based system, whether it is a bus system or whether it is a four-wheeler or two-wheeler or something. Some of the challenges which has already been told in the EV cases is particularly about the battery. This battery disposal is one thing, and then another is about the battery scalability, where the battery itself is based on the lithium base, and then lithium itself is a very scarce kind of a commodity, and we are only depending upon the only very few countries are having this kind of a hold. So probably in the long run we need to think about something else also. And with that in view, I would just like to mention about this EV technologies and hydrogen as an alternate fuel in the transportation. So what has been this kind of system where and how, what is the progress so far in case of the hydrogen? So hydrogen, I can say far more it is the most clean fuel, because it is something where you don't get any output, and it's only the output is only the water. So basically the advantage of the hydrogen as a fuel is you have a reduced import, because you don't depend upon the lithium battery itself. Energy security is there, you can have a long-term kind of a thing. Then it can address the climate changes very well, and then the decarbonization of different sectors and integration of renewable energy is also one of the key aspects of this. So being a technical session, so I have probably tried to focus more on a technical thing, and particularly those who are the electrical engineers and mechanical engineers, they may be able to appreciate more, but I think it's for the general kind of a thing where I just try to do it. So if we just talk about the hydrogen train, it has basically in 2019-26, it was unveiled by the Alstom as a zero emission train. Its name was Coradia Island. It was showcased in the Innotrans. And then right now probably Germany, as we also have one of the speakers from there. So they have been basically the pioneer into the hydrogen also. And as she said that it is basically in the Frankfurt, they have almost 100% EV. So the same way they are also going this kind of a thing. After the trial, they are right now operating almost 41 trains into into their country. And progress about the other countries was, I just want to mention about the global scenario. So everybody is trying to catch up on that, and Japan has already started in 2022. They are having this advanced pilot is in the progress. And China has already started, and then they are basically going in a large scale for passenger segment also, as well as for the freight segment. So that probably will be something where we need to think about it. Of course, it has certain challenges right now. And we talk about the US. US is also coming up with the initial operation has been started this year itself. Then France is also expected this year itself. And then I'm particularly focusing on the railways in the India, basically, where the Indian Railways has already launched one of the, it has already been developed and is likely to be commissioned shortly, I can simply say that. So they have planned first train in the mainline section on a broad gauge section, and there are another 35 trains which has been planned for the heritage route. So this is basically the project which in the railway I was associated with this project. We are planning basically to have retrofitment of 2 trains. One is basically one rake is having 2 diesel power cars, and then the 2 diesel power car, we were trying to retrofit it with the hydrogen system. The narrow gauge also, like Kalka Shimla, Darjeeling Himalayan Railway, etc. on the other heritage route. This is also been planned basically so that we should not have any kind of a pollution. It will be replacing the diesel. So this was something where we have just the scope of the work, where the onboard equipment was there, and fuel cell. I'll be coming a little in detail about that. And hydrogen train also, we need to have some hydrogen infrastructure basically, so that we can fill that hydrogen. And it's not a simple thing like filling of a gas or filling of a fuel or something. It's something little complicated. So so now I think just the basic building blocks of what are the building blocks of this thing. We have a fuel cell. Fuel cell, I'll be giving a little brief about that because the time is not much. So basically it converts DC to AC power, and then we have a traction converter which drives the traction motor. We also are supported by the lithium-ion battery to some extent, because these lithium-ion batteries are being used particularly for the purpose of storing the regenerative energy and also giving the power back to the system whenever we need more power. So it also helps in designing optimization of the fuel cell kind of a thing. So this is basically the kind of a system where we just try to develop the conceptual layout. We have a fuel cell module which is onboard system, and we also have hydrogen storage which can be onboard or it can be over the board, or then we have a traction converter, etc., battery module. That I think I'll just explain where we are having. Just to briefly tell you about thing, I think most of you is already aware about that. A fuel cell is basically a sort of system where we develop the chemical energy from the hydrogen, and it produces electricity. So hydrogen as a fuel, as I told you, that it is basically only produces electricity and water as a output. So this is one of the most cleanest fuels which we can say. Of course, the requirement of generation of hydrogen, that is something which we have to talk about. So hydrogen plus oxygen gives a water plus electricity. And then we also have that hydrogen and the reverse reverse process is the electrolyzer, where we generate the hydrogen using the electricity, or there can be number of ways of generating hydrogen. This is one of the way of doing that. Coming next is basically a fuel cell, because this is some kind of a new thing where probably few of you definitely must be aware. Just I want to, for the sake of understanding of everyone, I just want to explain basically the hydrogen, that fuel hydrogen comes as this thing, and then we have 2 electrodes, anode and cathode, which are of a platinum. So once the hydrogen comes into contact with the platinum, so it breaks into the hydrogen ion and the electrons. So hydrogen ions basically go through the electrolyte. Electrolyte is basically acidic polymer based electrolyte is there, and the proton passes through that, and the electron goes into the upper circuit, which goes through the electricity, and it generates the electricity. So that is the reaction basically which happens inside the fuel cell. And then the proton, this fuel cell can be of many types. Normally, the predominantly which are being used into the train is the proton exchange membrane, and where depending upon the type of electrolyte it is being clubbed together. So solid polymer membrane is there. Then we have alkaline kind of a thing, solid oxide, depending upon this kind of application. But commercially, the first type basically proton PEM-based, what we call them as a PEM-based system. So that is being used mainly. So the other is a phosphorus kind of a thing, phosphorus, then molten carbonate, direct methanol, etc. So now the very important aspect is because hydrogen is being used as a fuel. So where from we generate the hydrogen? Hydrogen can be generated from many ways. First is called as a gray hydrogen, where it is being, the steam methane reforming, it is being produced. So then we call it as a gray. And whatever CO2 is being emitted from this, if we try to capture that, or we store that carbon, or we sequestrate that, so in that case, it is turned into a blue hydrogen. And then green hydrogen is where we try to generate from the electricity, green energy, renewable energy only. Then we term it as a green hydrogen. And then we also call it as a turquoise hydrogen, which is basically a procedure what we call as a pyrolysis from the methane. We do it. Then wine hydrogen is also there from the coal gasification. We start working. So then the block diagram, basically this is something, this one is, if I talk about, this is the existing one. And where we just convert the left side, the topmost block into a fuel cell base instead of diesel engine. So this is being converted. And the fuel cell is having a boost converter, and then this kind of a, basically if there are 4 fuel cells are being used, set of fuel cells are being used into this. So just to explain about that, how it is there, each fuel cell is about 126 kilowatt capacity. So it is going to the converter. Then we have a lithium ion battery. Whenever we are having a fuel cells are being reproduced, are coming into the circuit one after another as per the requirement. Whenever there is excess generation, it goes to the lithium ion battery, then it goes to the traction converter. And it is...
Conclude.
Okay. So just fuel cells is basically, okay, I'll just pass through quickly. And this is some technical data. I think those who are interested can just see it. So basically this is something, the layout where we have just we have underlying equipment, the battery system, air compressor, and etc. This is all there. I think to those who want, they can discuss with me, given a little less time. So onboard system are basically hydrogen. Then we are having a fuel cell and main batteries. So these are some main system on this.
Sudhir, we have to conclude. There is some other urgency coming.
Okay. So this is something where I'll be coming to this part now. This was something the hydrogen, some of the way forward is what we can try to work is on that. Basically, this hydrogen train can be used for the spur lines in RRTS metro system up to depot, then it can be used for shunting application. We can have this tower core also. And this way, probably we can try to do it. And thank you.
Thank you. Well, I think just a word from you, only one liner from you I will require. That is, for the hydrogen to be recharged back into the train, how much time does it require?
It doesn't take time actually. It's dispensers are there. It is running at a, we are doing it through a compressor. We are having a ground storage of 200 bar pressure and 600 bar pressure. From there, we either use a dispenser, and then it takes hardly 5 to 7 minutes to fill the entire.
So it's possible to replicate in the bus. Thank you. Gentlemen, I believe we have been asked to curtail our session, and this something which all of us must come to terms with, because the CM is expected to be here. So with that, and due apologies to other speakers, I may just ask one line question to Mr. Prashant. You have trained 40,000 people. There was a talk of Chinese products coming in. What would you like to leave one-liner advice for the Indian artisan and the other people who serve the industry? How could they be trained?
I believe your question is from the skilling side. So definitely, I think that's one point which that's one key point which should be discussed. I believe a very technology-driven and specific skill requirements are there when it comes to electric vehicle technology today. So I believe there is a very strong requirement for making our skilled workforce to handle the new age battery technologies, the new age power electronic technologies. As these are very complex electronic components, it's very important for them to be skilled and trained on the way how to handle these battery packs as well as the power electronic components from a service and maintenance perspective. So I think all our skilling agencies like Automotive Skill Development Council, ASDC, kind of people, they are definitely working on these areas, and they are already preparing qualification packs focused on battery service and maintenance, electric vehicle service and maintenance technicians area. So I believe these measures should be continued with a strong support from the OEMs also to ensure that the required skill sets are provided for the people.
Thank you. I think with that, we would come to a conclusion of this session. And however interesting it gets as we get into the detail, but it must come to an end. I must thank the panelists here for having spared their time and given their views. It has been very wide from different perspectives, from the economists, the financiers, the people who are operating taxis, people who are policy makers, the alternative fuels, and people who are actually in the charging business. So thank you all once again. I'll hand over the mic to the organizers to give the final conclusion.
Thank you, Chairman, sir, for conducting the session so smoothly and keeping the discussion live. Now, I would like to request Honorable Sir to kindly present the memento to our esteemed speaker in order of their appearance as a token of appreciation for their valuable contribution. Mr. Praveen Yadav, Managing Director, Electrify Private Limited. Mr. Prasant Kumar Palani, Founder and Chief Technical Head, Harita E-Mobility Solution. Mr. Sanjay Chadda, sir, Head of Public Policy and Government Relations, Uber, India and South Asia. Mrs. Veronica Plates, Principal Portfolio Manager, Climate Finance and Mobility, South Asia, KfW Development Bank. Sri Sudhir Kumar Saxena, sir, Group General Manager in NCR cities. Thank you. Now I would like to request Professor Ashish Verma, sir, Indian Institute of Science, to kindly come on the stage and present a memento to Honorable Chair of the session as a token of respect. Thank you, sir and madam. As we conclude, I, on behalf of Ministry of Housing and Urban Affairs, wish to express heartfelt gratitude to all the dignitaries, speakers, and participants for their valuable contribution in making this session a success. Thank you all. And before we close, I would like to announce and invite you all for the session on urban transport will be held here at 4:30 p.m., which is going to be graced by Honorable Chief Minister of Haryana. Everyone is requested to kindly be seated by 4:15 p.m. here. Thank you so much. Thank you all.